Hi guys, Mrs. Suya here. These notes are going to cover the second day of section 1.4 where we work on our two-column proofs. Day one covered basic information about angles. So our proofs are going to be using angles. Okay, so before we do our two-column proofs, I need to show you the language that is going to be being used on this set of notes. It's posted in Canvas, so go ahead and open it up at the least, print it off if you can. They should eventually make it over onto your gold sheet so that you have everything on your gold sheet. Okay, so the first one is a postulate. So remember, a postulate is a math statement that is assumed to be true, not proven to be true. They're usually very basic, not very hard to understand. It says, if two angles are right, then they are congruent. All right, so if this was a right angle, usually it should be marked with a box, and this was a right angle, then you would be able to link these two angles together and say they are congruent to each other based on this postulate. Number 9 says right angle definition. If an angle is 90 degrees, then it is a right angle. And then definitions also have converses. All right, so postulates do not. That's why we didn't write a postulate. But definitions, that's the mark of a true definition, is that you can use it one direction and you can use its converse. So this says if an angle is 90 degrees, so if you knew this angle is 90 degrees, right, then you would be able to say that this angle is right. I know it seems like we're saying the same thing, but it's in a two-column proof, numbers and words are slightly different. All right, and this converse says if an angle is right, then we can say that it is a 90-degree angle. Okay. Congruent angles. This is also a definition, which is why we have a converse for it. So it says if two angles have the same measure, then they are congruent, such as, if this was a 100-degree angle and this was a 100-degree angle, we would be able to say they are congruent because they have the same measure. And then its converse, if two angles are congruent, then they must have the same measure. Okay. A postulate. Angle addition postulate. It's like the sibling to the segment addition postulate. So it just says if you have two smaller angles like this, you can add them together and it should equal the sum of the big angle. Right, and last one is angle bisector. So this is also a definition, so it includes a converse. If a ray bisects an angle, then it divides the angle into two congruent angles. So if we were given, here's a ray, if we were given that it bisects the angles, the big angle, then we would be allowed to say that these two little angles are congruent to each other. All right, and the converse is if a ray divides an angle into two congruent angles, so if that ray gives you two congruent angles, then we would be able to say that this bisects the angle. All right. Oh, I forgot to say that you can disregard these numbers on the left here. Just make them kind of line up with wherever your gold sheet has left off. Okay, first two-column proof. Remember, you're given a diagram and some information, and then we are trying to prove something. Okay, so first of all, we're going to go and mark what we can. Angle ABC is a right angle. So to find the angle ABC, you put your pencil on A, trace it to B, over to C. So we traced this bigger angle here, and we were told it's a right angle, so I can put a right angle marker on it. Notice there's this ray BD here that's not mentioned at all over here, and we are not going to be able to, or not need to use it at all. It's just added information on the diagram. Just ignore the ray. All right, angle X is a right angle. So this angle over here, we can call this one X because it's the only angle at X. Unlike over here, this one we couldn't call B because there's three different angles here. These two small ones and then the big one that we actually are looking at, the angle ABC. All right, so it totally makes sense in our mind. They're both stated to be right angles. So it's like a no duh, of course they are congruent. That's all we're trying to prove, that those two angles are congruent. But remember, we have to use something out of our gold sheet toolbox. All right, so the thing we're going to use is postulate 8. If two angles are right, then they are congruent. Okay, so we are going to write. Of course, first step is always to write our givens. I'm going to shortcut and say angle ABC is RT for right. Angle X is RT. All right, so we have just stated these two angles are both right, which means we can link these two angles together. We can say they are congruent to each other. And then the if-then structure, right? So the if part has to refer to what has happened up above. And what has happened here is that we have shown that two angles are right. Right? Then we can say they are congruent. If two angles are right, then they are congruent, meaning these two angles are congruent. All right, so just some observations. Left-hand side is short symbolic statements specific to the picture. Right-hand side is generic language, totally from structured language that we are being given to use. We're not just kind of making it up. Okay, next one seems like it's just almost identical. So angle ABC is right. ABC is right. Again, ignore ray BD, unimportant for this problem. Oh, actually, it doesn't say it's a right angle. It says it's 90 degrees. I'm going to erase my little box. I'm going to try to mark 90 degrees instead. So it is a slightly different. And here it says angle X is a right angle. All right. So measure of angle ABC is 90 degrees. I'm going to just do something on here. I'm going to separate my givens because here is something that is going to be hard to find out of the book. So make sure you pay attention. In a two-column proof, the number 90 is treated differently than the word right. And so in order for us to use this definition that if two angles are right, then they are congruent, we have to make them match somehow. So we are going to use a definition to say that that 90-degree angle is actually going to be a right angle. Okay, so if we look over here, we do have a definition of a right angle. It says if an angle is 90 degrees, then it is a right angle. So this is our link between the number and the word. All right, so I didn't write my second given yet. I'm going to just, this one given lets me say one very specific thing here. Okay, and then we're using our definition from our paper. If an angle is 90 degrees, or maybe if the measure of an angle is 90 degrees, then it is right. So if this happens, measure of angle ABC is 90 degrees, then it, as in that ABC angle, is right. Okay, now I'm going to bring in my second given. So you can use your given, you can put them all on the first step, or you can use them as you need them. So now I've established that these two angles are both right, so I can say that they are congruent to each other, right? That's what we were trying to prove. Also on a two-column proof, just remember the very last step is always supposed to be what you're trying to prove. If two angles are right, then they are congruent. Okay, that could have been a three-step proof if you put everything on all the givens together. All right, next two-column proof, exact same picture, but this one's a little bit more sophisticated. So we're going to go ahead and mark over here. Oh, and we're still trying to prove those same two angles are right, or congruent. So we're given that the measure of angle ABD is 30 degrees. Now we're going to do something with that ray thingy. Okay, so to find this angle, right, ABD, put your pencil on A, trace it to B, up to D. We totally just traced this angle right here, and we were told that it is 30 degrees. All right, now we'll do the same for the other angle. Measure of angle DBC, D to B to C, is 60 degrees. That angle right there. So in our minds, hopefully the little light bulb is going off that if you add those two numbers together, you get 90 degrees. And the thing that would allow us to add those together is the angle addition postulate. Okay, so once we're going to get 90 degrees, then we're going to say that that 90-degree angle is a right angle, and then we're going to be able to say that this right angle and the angle x, which is also right, are congruent. So we're going to use a couple different things here from our sheet. We are going to use the angle addition postulate, this one that's labeled number 13. All right, and then we're going to use the definition of a right angle to go from the number to the word. And then we're going to use our definition. If two angles are right, then they are congruent. All right. Okay, again, I think I might split up my givens because these two numbered angles, the ones with the degrees on them, those two are going to join together, and so I just kind of want to use these two for the time being and ignore the rest of my givens. All right, so in a two-column proof, you don't have to show any arithmetic. You can totally just add these together and get that 90-degree angle, right? And then you just have to look at your diagram to name that 90-degree angle. It's the angle ABC, right? It's this big angle right here. Measure of angle ABC is 90 degrees. All right, so we use the angle addition postulate, which since this is the first time that we used it, I wrote it out, but in general, you can just write angle AAP, angle addition postulate. Okay, and now we have a 90-degree angle, right? These guys are making the 90-degree angle. The other one is said to be a right angle. So we're going to turn that 90-degree angle into a right angle. And we're going to take a step in our proof to do it. Okay, angle A, B, C is right. Let's see, that was our definition of a right angle, right? This, the one that's labeled number 9. This is links the number to the word right. If an angle is 90 degrees, then it is right. So if this happens, if an angle is 90 degrees, then this happens, then it is right. All right, now I know it seems kind of out of order-ish, but I kind of like how this lines up. I'm going to go ahead and bring in my second given, which is to say that angle X is right. That's just given, that's why I can say it. And now I've got it, totally got it lined up, right? I have these two angles are both right angles. So I can tie them together and say that angle ABC is congruent to angle X. For the same reason I used on my last step on the first two proofs that we've worked. If two angles are right, then they are congruent. All right, on the back side, two more proofs. So we were given that ray GB bisects. It's always nice to get a vocab word in here because then you kind of know on your gold sheet where to look, right? You're going to look at for anything that says bisect with it as to what you could do with it. Bisects angle AGC. All right, so here's ray GB. This guy right here. Angle AGC is this angle right here. Starts at A, goes to G, over to C. So this big angle is getting bisected. All right, so we'll look over here and we'll look at kind of our definition of angle bisector, right? If a ray bisects an angle, that's what we had, then it will divide the angle into two congruent angles. Okay, so the two resulting angles here are congruent to each other. And hey, look at that. That's exactly what you're trying to prove. Angle AGB AGB, this angle right here, is congruent to angle BGC. So trace out BGC. All right, so this is just a two-step proof. So with only one given, there's no choice about what to write on step one. Just put your given there, right? Angle, or ray GB bisects angle AGC. And that is given. All right, bisect. You use it with segments or with angles. This one is being used with angles. It always leads to something that's going to be congruent. That's a very, very common sequence of steps. So you just have to figure out what is going to be congruent. And we already looked at that. We said it's this angle, AGB, and BGC. Those are the ones we're trying to prove congruent. All right, and we're going to get our if then. So if this happens, if a ray bisects an angle, then it, as in that ray, divides the angle into two congruent angles. That's what we're allowed to say. Okay, and now same diagram, but we're just our givens and what we're trying to prove is kind of swapped around, so we're going to be reasoning from the converse kind of stuff. At any rate, we have angle AGB is congruent to angle BGC. So if we go find AGB, this angle right here, is congruent to angle BGC. BGC, trace it out, and put matching arc marks. Okay, so if those two angles are congruent, then what we can say is that the ray here, GB, is bisecting the big angle, AGC. AGC. Okay. So, I didn't do a very good job of commenting about when to use the straightforward definition versus when to use the converse, but it is all about the if-then structure of it all. Okay, so this is ray GB bisects angle AGC. Okay, so let's investigate this angle bisector definition. I'm going to fold this down. Can I fit it in here? All right. So remember, the if part is supposed to refer to what has happened up above. And what has happened up above is that all I have stated up here is that I have two separate angles. So the language doesn't match quite as nicely as it did on the upper one, even though I didn't go through this step. But I don't have if a ray bisects an angle, right? Because I would have to show up here that I have a ray that's bisecting an angle. And I don't have that. So I know it's not the straightforward one. I know we're going to be using the converse, which says if a ray divides an angle into two congruent angles. That's what I have, these two congruent angles. And you have to look at the diagram to tie the rest of it together, because these two congruent angles are part of this big angle that's got this ray going through it. If a ray divides an angle into two congruent angles, comma, then it, as in that ray, bisects the angle. And so the then part refers to what is happening here, right? It, as in the ray, bisects the angle. That's exactly what we have stated. Okay, good luck with your 2-column proofs.